Next is Kirchhoff's voltage law or KVL. It states that the algebraic sum of the voltage drops in resistors plus the algebraic sum of the EMFs acting around the circuit is zero in a closed mesh. In other words, KVL states that the algebraic sum of potential rises and drops around a closed path is zero. Look into the picture. We can trace a continuous path that leaves point A through R1 and returns through E without leaving the circuit. Therefore, ABCA is a closed loop and a plus sign is assigned to a potential rise and a minus sign is assigned to a potential drop. Here we can see there is a potential rise in the battery voltage, that is minus to plus, and there is a potential drops in the resistors. According to Kirchhoff's law, we get plus E minus V1, that is a voltage drop V1 across R1 and V2 across R2. So plus E minus V2 equal to 0. That is, we get E equal to V1 plus V2. And if we apply a current I in the circuit, we get E equal to I into R1 plus I into R2, where I R1 is the voltage drop in the resistor and I R2 is the voltage drop in the resistor R2. Let us do a simple problem. For the circuit shown, determine the unknown voltage drop V1. Here there is a potential rise and in resistors potential drops is there. According to Kirchhoff's voltage law, the sum of potential drops is equal to the sum of potential rises. That is, we can write here there is only potential rise, only one potential rise, that is 30 equal to sum of potential drops 2 plus 1 plus V1 plus 3 plus 5. That is 11 plus V1. From this we get V1 equal to 30 minus 11 equal to 19 volt. Next problem. For the following circuit, determine V2 using KVL. Second one, determine current. Find R1 and R3. And this is the circuit. So first of all, assume a direction for the current and look into the EMF given. Here this is negative and this is positive. So assume a current like this. Let I be the current. Now applying KVL. E equal to V1 plus V2 plus V3. And here voltage drops are plus minus like this. And we know E, the value of E is 54 equal to V1 18 plus V2 we have to find and V3 is 15. From this we get V2 equal to 21 volt. And V2 is nothing but I into R2, that is voltage drop is IR2. From this we get I is equal to V2 by R2 equal to 21 by R2 is 7 ohm equal to 3 ampere. And next we have to find R1 and R3. R1 is V1 divided by I equal to V1 is 18 volt. 18 divided by 3 equal to 6 ohm. And R3 equal to V3 divided by I equal to V3 is 15 volt. It is given 15 divided by 3 equal to 5 ohm. Next problem, find the current in the circuit and the voltage across each resistor. This is the circuit given. Here these two are in mega ohms and these two are in kilo ohms. So first convert this kilo ohm into mega ohm. That is 500 kilo ohm is 0.5 mega ohm and 400 kilo ohm is 0.5 mega ohm. That is divide by 1000 or multiply with 10 raised to 3. We get in mega ohm. That is 1 kilo ohm divided by 1000 equal to 1 mega ohm or 1 into 10 raised to 6 ohm. Now redraw the picture and assume a current direction. Here there is a potential rise in the battery in this manner. So give a current direction in the clockwise way. And applying Kirchhoff's voltage law, we get 10 equal to, here voltage drop is 1 mega ohm into I. That is 1 I plus 3.1 I plus 0.4 I plus 0.5 I, and we get 5I equal to 10. From this we get I equal to 10 by 5 equal to 2 microampere. That is, here 5 is in mega ohm. That is, here voltage drops are there. That is resistance into current value. That is, resistance is in mega ohm. So here into 10 raised to 6. 5 into 10 raised to 6 is there. So we get 2 microampere. That is 2 into 10 raised to minus 6. Now the voltage drops across each resistor is, voltage drop across 1 mega ohm resistor is current into that resistor. That is 2 into 10 raised to minus 6 into 1 into 10 raised to 6 equal to 2 volt. And across 3.1 mega ohm is voltage across 3.1 mega ohm. 3.1 into 10 raised to minus 6. Sorry, 10 raised to 6 into current value 2 into 10 raised to minus 6 equal to 6.2 volt. Similarly, across the 400 kilo ohm resistor, that is 0.4 mega ohm resistor is 0.4 into 10 raised to 6 into 2 into 10 raised to minus 6, that is 0.8 volt. And across the 0.5 mega ohm resistor is, or across 500 kilo ohm resistor is 0.5 into 10 raised to 6 into 2 into 10 raised to minus 6, that is 1 volt. Next problem. For the following circuit, find the currents in the resistors R1, R2 and R3. This is the circuit, and this is one of the important problem in the exams. First, assume direction of current, and there are two loops, that is, this is one loop and this is the second loop. Let A, B, C and D be the junctions or nodes. Then first loop is A, B, C, A, and second loop is A, D, B, A. First assume current directions. Let clockwise direction be the current in the loop A, B, C, A, and here there is a potential rise in the battery in this way. So assume anti-clockwise direction I2 in the loop A, D, B, A, or assume loop like A, B, D, A. Now applying KVL to loop A, B, C, A. Here I1 flows through the resistor R1 and here I2 flows through the resistor R2, and through R3 the sum of these two currents are flowing, that is, through R3 the current flowing is I1 plus I2. So applying KVL in this loop, we get 15 minus 10 I1. 10 into I1 is the voltage drop in the resistor R1. And in this resistor, the voltage drop is current into resistor. That is, current is sum of these two currents. That is, I1 plus I2 into 5 equal to 0. Now simplifying, 15 minus 10 I1 minus 5 I1 minus 5 I2 equal to 0. Now we get 15 equal to 15 I1 plus 5 I2, that is 3 equal to, simplifying the equation, 3 equal to 3 I1 plus I2, that is 3 I1 plus I2 equal to 3. This is the first equation. Now applying KVL to loop A, B, D, A, we get 10 minus 15 I2 and through resistor R3 minus I1 plus I2 into 5 equal to 0. Now simplifying, 10 minus 15 I2 minus 5 I1 minus 5 I2 equal to 0. That is 10 equal to 5 I1 plus 20 I2. Or we can write 5 I1 plus 20 I2 equal to 10. On simplifying, we get I1 plus 4 I2 equal to 2. This is the second equation, and first equation is 3 I1 plus I2 equal to 3. Now simplifying these equations. First multiply equation 1 with 4, or you can multiply equation 2 with 3 for equating the coefficients of either I1 or I2. So multiplying equation 1 with 4, we get 12 I1 plus 4 I2 equal to 12. So this is the new equation. Now simplifying equation 3 and 2. That is equation 3 minus 2 implies 11 I1 equal to 10. From this we get I1 equal to 10 by 11. And by substituting the value of I1 in either of these equations, we get I2 equal to 3 by 11 ampere. That is, if we substitute the value of I1 in the first equation, that is 3 I1 plus I2 equal to 3. From this I2 equal to 3 minus 3 I1, that is equal to 3 minus 3 into I1 is 10 by 11 equal to 33 minus 30 by 11, that is 3 by 11 ampere. Also we have to find the current through resistor R3. The current through resistor R3 is sum of I1 and I2. That is equal to I1 is 10 by 11 plus 3 by 11 equal to 13 by 11 ampere. Thank you for watching the video. If you like the video, please like, share and also subscribe my channel.